As an accomplished software engineer, I always wondered how these digital things and analog circuits really work. So today, after a couple of days of trying out different things, so I got my first working NAND gate. So, in my first working NAND gate, I used 3 transistors and I used several resistors for which I'm going to share the details in my article, and which I will put in the description down below. But everything I tested it, it works, so it was a bit of a trial and error to do it right. Of course, I don't like the fact that these wires are quite long, but it should be manageable. And let's put it to work. So I've got my 4.5 volts battery, which was depleted and works only with 3.3 volts. So as you would expect from an AND gate, if both of the inputs are 0, the output of the gate should be 1. So as we can see indicated by the LED, it's going to be 1. If I press one of the buttons, still it should be 1 because it's a negation of the AND gate, where in the AND gate we want everything to be 1 if all the inputs are 1. So practically now if I press both of them, the LED should be off, you see? And it's a very easy logic, but doing all this by myself was a bit tricky because I'm used only to software engineering, and as far as programming goes, I didn't go lower than C under Linux. So it was a bit of a challenge. So for those of you out there who are really into electronics, for you it might be a piece of cake, but for me it was quite something, and I still don't understand all of the mechanics, but all these resistors that I use, they seem to be working in this configuration, and I change them so often that I don't really remember the values for them, but the logic seems to be good. And yeah, practically these 2 transistors, they are NPN transistors, and this produce the end result. And the last transistor that we have here is going to produce the inverter. So it's going to invert the output of the AND gate, which is there. So it was a bit tricky to get it working at the first time. So I had this problem that if I press the input number 2, the LED was dimming and not you know, it was not kept on, but I managed to get my head around all these resistors and to do this result. Now, why I chose an AND gate is because this is a universal gate, and based on this gate you can practically construct all the other gates, which is very cool, and it's like to me it's like the first step into electronics. Now, I also have my PicoCalc kit right here, and with this one I want to read the input on the device. So if I turn it on, we can see we have already the things booted up, and just a second to align this. So what I don't like is that this display is very glossy, so you might not be able to see properly into it, but it should be fine. So if I'm using the set pin command, I'm going to write it here, set pin. I usually use this GP28, but let's try with GP2 pin. Set pin GP2, and we want to use it as a digital in, and we say DIN. You can see it right here. Now I purposefully just left two wires from the LED output just to see the input on the PicoCalc. So this is the plus, which corresponds to the plus of the LED, and this is the ground. Okay. And I put it into the ground. Okay, the LED is brighter. Hope. Something I did wrong, I suppose. No, I didn't do it well. So this is practically the 3 volts. That's why the LED was really brighter. Yeah, so the logic of the gate should be preserved. And now if I want to return the value of the gate from the PicoCalc, I just say pin G28. No, GP28. Yeah, it gives me an invalid syntax because I need to use a command to print it. So I use print So let's see what is the value. Oh no, sorry, it's GP2, not 28. I used GP28 before, so that's why. So we can see the value is 1. Now what happens if I press both of them and print the same value again? Sorry. Now the value should be 0. If I print it again, should be 1, 1. Print it again, should be 0. And this is super cool. I really like it. Should be 1 again. You see, all in a couple of commands I did this kind of input for my logic circuit. Now I would like to create, because this is a breadboard, so this is for test, I would like to create it on a PCB, to solder it, so that I can also, you know, harden my skills on soldering as well. It will be interesting and fun as well. Then I will use it to recreate, like educationally recreate, the Boolean algebra of the logic gates. So bear with me with this project. I'm going to learn a lot of things about electronics. So if you are there searching for some interesting videos about electronics and how these devices work in general, just follow my channel and you will be informed with the latest and greatest. Thank you so much.